Okay, in today's lesson, we're going to look at the explicit formula for both arithmetic and geometric sequences. We've already talked about arithmetic sequences this year, so we're really just going to add in the new piece of looking at geometric sequences. Please write down your essential question and restart the video when you are ready. Okay, so in the first examples, we want to determine if the following sequences are arithmetic or geometric. It really goes along the same pattern of determining is it a linear set of data versus an exponential set of data. So if we look at this pattern, we notice that there is an adding pattern of 5. We would consider that linear or an arithmetic sequence. Okay, in the next one, you'll notice that the pattern, we are multiplying by -3 every time. Now with sequences, the pattern can have a negative number. So because it's a multiplication pattern, then this would be considered an exponential or a geometric sequence. And so I hope very easily you can see the differences between an arithmetic and geometric sequence. I want you to write down the answer to that question on your own, and we'll double check you tomorrow. So it says find the common ratio. So the common ratio is just the difference between each term, just like we've been finding. So just practicing here, finding that common ratio. The common ratio here is times 3. Really easy, right? Okay, check for the next one. What is the common ratio? If you weren't sure here what the common ratio is, remember you could take any 2 consecutive terms and divide the one on the right, and I'll just take 5 and 15, divided by the one on the left. And so you should be seeing that the common ratio is a pattern of multiplying by 1/3. Okay, and then the last one, really easy. Again, the pattern is multiplying by -2. That's your common ratio. So we have to be able to identify the common ratio. So let's talk about what the formula is, the explicit formula for geometric sequences. Okay, the formula is a sub n equals a sub 1 times r to the n minus 1. You could also see this as f of n. That's another way to write it. A sub n just represents whatever term you're looking for. A sub 1, remember, represents the first term in the sequence. And then the r stands for that common ratio that we're finding. I want you to notice, we've seen some rules like this. This is a multiplication. There's no adding or subtracting, versus what the explicit formula for an arithmetic sequence looks like. So I want to write that down here so that you can see that. Remember, its formula is a sub 1 plus the common difference times n minus 1. So one of the key features that you can tell here is, number one, we're not raising it to a power, and we've got this addition right here. So that just tells you that you should be adding between terms, whereas opposed this one tells you you should be multiplying between terms. Okay, so what I want us to look at here is I want us to write an equation to represent this sequence. And so what we need to do first is find the common difference. So hopefully you see the common difference here is times 4. And so using our formula from up above, the first term is 5. So we would say 5 times 4 to the n minus 1. Okay, I want you to see if you can write the rest of the equations yourself.